Welcome to qnawire.
Let's look at what numbers we have here first. So apparently we have a 100 Newton, the force that is pulling the string at the beginning. So that's labeled as F1, equals to 100 Newton. And then we have, it's increased into 120 Newtons. So let's say we have F2 equals to 120 Newtons, 20% greater than the F1. And then we know that the length of the spring, by increasing the force, we also increase it to by 5 centimeters. So if we say it's delta x, the difference between the new x and the old one, delta x is going to be 5 centimeters, and let's convert it into meters for future calculations. So it's going to be 0.05 meter. That's all we have. So the question is asking us to figure out two variables. The first one is the spring constant. Actually, it's a constant, yeah. So in order to figure that out, we need to use the Hooke's law, F equals to kx. And we don't know k, and we don't know x yet, but we have two f's, and we know the difference between the x, the two displacements. So we can form a system of equations. The first one is F1 equals to k times x, the original displacement. And if we plug in the number, it's going to be 100 Newton equals to k times x. And the second one is F2 equals to k times the new displacement. K is always going to be the same because it's the spring constant. But we're going to have a new displacement here. It's x, the original displacement, plus delta x. And if we plug in the numbers, it's going to give us 120 Newton equals to k, x plus 0.05 meters. This is a system of equation. And now let's label this as equation 1 and this as equation 2. So if we use equation 2 minus equation 1, it's going to give us 120 Newton minus 100 Newton equals to kx plus 0.05 meter minus kx. And simplify it a little bit. 20 Newton equals to kx plus 0.05k minus kx. And you can see that the ks just cancel out here. So in the end, we have 20 Newton equals to 0.05k. And nice, we only have one unknown here, which is k. And that's what we're looking for. So in the end, we can say k equals to 20 Newton divided by 0.05. And be careful because I kind of missed the unit here, but you should always try to write out the unit just in case you don't make any unit mistakes or cause any confusion. So as for now, we have 20 newtons divided by 0.05 meters, and that's going to give us 400 Newton per meter, and that is the spring constant. Since we have the k now, it's going to be very easy to figure out the x, which is the second part of the question. So we go back to the Hooke's law, F equals to kx, and we plug into either F1 or F2. It won't make a difference, but let's just say F1. So 100 Newton equals to 400 Newton divided by per meter. That's a k, and times the original placement x. Oops. And that's going to give us 100 Newton x equals to 100 Newton divided by 400 Newton per meter. So we know that F equals to 0.25 meter, which is 25 centimeters. And that's the answer for the second part of the question.